and grid dynamics. And last time we conducted our event at Residue. So this was a snapshot of our past events. So to know more about ourselves and get to know about the upcoming events and our initiatives, you may scan this code to access our website that we have launched. Okay. Thanks. So yeah, what's in for you today is we'll start with the icebreaker session and followed by a welcome address, and then we will have the technical sessions. We have three sessions planned today, covering from the self-service aspects from tickets to autopilot, and then we will go for a short break, and then we'll connect and network. Then followed by the second session, which is from DB to DOM to AA, and followed by the third session, which is based on loop validated AA loop engineering. And yeah, we'll close with the feedback session and lunch and networking. So I invite Jairam. Okay. Just a moment. Hey, hi everyone. My name is Jairam. I work with Ford. So for the icebreaker session for today, we have to find more related to DevOps terms or software engineering terms. Any idea? Docker. It's Docker. So that is Kubernetes, yes, Kubernetes, yes. It is. It's a bit difficult though. Maybe I can give it Jeff. It is one of the IAC tools. Infrastructure. So you will see what action they perform. They're pulling. Pulling, yes, pulling. So that's a luminescence. So it's difficult though, yeah. This is easy. Though. Yeah, it's not. Yes. It's an operation, yes. GitOps. Okay. This is one of the security terms. You can see what is the expression you see. O. So, O. Yeah. How about this one? Power. It's power. It's difficult though, but you could. It is one of the automation too. Power. Google Cloud.
you go from the last, that might be easier. Overall, as a setup, they call it as system. What is Google.com?
I mean, DNS.
DNS, yes, DNS. Services. These are like, it's one of the Kubernetes term maybe I will make it easier now. Can you go back once? So the middle person feeling what? Full. Stateful.
Stateful, what is the last?
Set.
Set.
This is easy, very easy. Yes. Right. Good. Okay, so we have two options. So maybe you could raise hands. Whoever writes the left hand side one, so you can raise the right hand, and then the one in the other one you could raise the left hand. So who likes tea more?
Brit or yours, left Brit.
Tea or coffee person? Like whoever likes tea.
Need to raise the hand.
Raise the hand, yes. Tea. Tea. Okay. It's very less. What about coffee? Most of them are coffee. Nice. Like morning person or like night owl? Morning person.
We are the box.
24 hours. This is easy. Definitely work from home or work from office. Work from home. Jogging person or walking person? I like to walk. Personally, I like to walk. That's all. Sitting person. That's not an option though. But I like that option. This is good. Clearly. Yes. No software developers like Intel. Intel.
Anti-gravity.
Anti-gravity.
From the IDE, anti-gravity is Claude.
Claude.
Right.
No Gemini, ChatGPT. No.
Just a second.
Thank you, Jairam.
Yeah, I have one more.
Kindly.
You are not tracking us anywhere, right? So this is slide of the
Just
So better click the polls.
Yeah.
Yeah, click the polls. Once you start, and then you'll see the question. Unless you don't connect, it will not work. You
No, no, I think the details.
Yeah.
It will be mobile side.
Correct.
No. Okay, there is something.
Yeah, we have
We just
the first-
started.
Yeah.
You would have seen the first question. This is a confession one, so you can just feel free. It's not recorded, so you can just feel free to say. This is very common practice we do. It's good or not, it's up to us. Seems like many used to do the same practice.
You want to share with the screen? That will be nice to.
I think they can see it in their phones itself. Like, what are they doing?
We'll move on to the next question.
This is the next question.
So the dinner is that approved 200 lines. Yeah.
No, they're cloning and then messing it up. Yeah,
Okay.
I often do that.
What happens? All are equally potential. 33.
There are two things which is dominating. If you see, they don't even worry about what is the test. It's just merging it to the main one.
Yeah, but now 60%.
Seems like we are very cautious about sensitive data.
Okay, we'll move on to the next question.
The last option was maybe from the last one.
Oh, so it's a bit-
Universal.
But never did. That's the last point. But never did.
It's like what happens in Vegas stays in
Stay
Vegas.
together.
Thank you.
Bala will be leading the most.
Big and warm thanks to people to give you a clue on what's happening on the overall GPN tries to do in the past and then what we are trying to do in the days to come. As we are making our name called Global Platform Engineers Network, though we started from Chennai, this is our first initiative to see that whether something can be done from the Bangalore part, and we want to see how we can grow and then try to contribute to the community, not just by sharing what we do, also by listening what's happening. So with that in picture, let me just, this is our LinkedIn site. Probably if you can scan that, you can go to the LinkedIn page and then you can follow what we guys are doing. This is our website as well, globalplatformengineers.net. And we are around 1,900 members in the meetup, and consistently around 100 plus generally showed up in our meetups in the past 8 events. This is our 9th event. We touch upon cloud, CI/CD, release management, and FinOps so far very intensively in the past 8 to 9 sessions. We want to slowly lay some foundation on security aspects as well, which is DevSecOps, and then a platform engineering as well. We started from this time with the help of Barney, and then observability aspects and developer prod tools engineering, where we will improve the productivity of the developer. What are the tools we have? We even touched on that in the first instance itself, which is our dev lake. And then performance engineering, Praveen is going to touch upon that part. So looking forward to that session. And data analytics and platform. So what we communicate through this slide is there are around 10 broader areas which we are trying to cover it as part of the platform. Today, platform is not about just laying the pipeline to move to the respective environment. It has moved much beyond. The concept of platform engineering initiated with removing the cognitive load of the developer. I'll substantiate with few artifacts what I have learned through in the recent times. And earlier we called ourselves as a platform engineers from Chennai, and then we transformed 1.5 years before to coin out this word called GPEN, Global Platform Engineers Network. Our mindset is to break the glass ceiling of location, right? We don't want to stay with the location when the world is easily accessible through an MS Teams or a Zoom call. And second is we don't want to limit ourselves with just one aspect of the DevOps. We want to migrate ourselves towards platform where we will cover all the 10 areas. And we want to purposefully global because we want to explore the new areas and update ourselves, including AI. And then we have the quest for excellence and then embrace the digital transformation. So that's the thing. Our slogan is connect, learn, inspire, and grow. So that's what our slogan is. This is a quick memory lane. We started in November 2024 with the first event. We had around 81 members, around 141 registrations, 3 sessions. And then from there, we had a December 2024 event, second event, and then Q1, Q2, Q3, Q4. From 2025 onwards, last year onwards, we planned, because it's a community service, we want to do one event at least per quarter. That's the thing we have embraced for 2025, 2026. We want to slowly ramp up and then see how we can be able to do that. We could see that in all the 4 events, we haven't touched on the 4th place. The last time when we hold GPEN event in the campus is November and December 2024. The complete 2025, all the 4 events, M2P, Uni, SQ1, again M2P. Thanks to Barney for partnering with us. And then in the 2026, this is our 9th and 3rd event. In the year, it is 3rd event, and overall, it's a 9th event. So we have done it in, I think, first one where we have done I think Unique we have done it, and then the second event we have done it in Grid Dynamics, and then here in our 4th Bengaluru campus. So, and the next event we are planning to do it on 12th December on the topic of agentic development platforms and the new TV, and we would like to beam it at the YouTube. Like even today, our sessions are going live in the YouTube. Couple of quick thoughts on where the things are moving. This is the ID CEO research happened in 2025 FADE. I have the opportunity to attend this event in Chennai, done by the IDC research firm, and they clearly mentioned that there could be a potential of 1 billion AI agents worldwide by 2029. And what is more interesting to that is there can be employees which will be something like this, 40,000 employees and 23,000 agents. That's the future. And we are not watching out the Interstellar movie. For sure, this is the way the overall things will be evolving. Okay, so what? There are things which are happening around the platform engineering, and I have curated with very few slides how the shift is slow and steady, which is happening on this space. The days where we were talking about the platform as an experimental cost centers are over. Where we are moving towards is platform engineering thing with the maturity, it can systematically multiply the developer output by 3x to 5x, right? So the strategic reality is platform engineering consolidation is a given path for all the established and budding organizations. No longer we used to have a small DevOps team, small DevSecOps team, and small SRE teams, and performance teams. So all this are all trying to amalgamate and then see that how do you have a combined value proposition. The biggest problem what we are trying to solve is not about writing code. We all know how the writing code is getting day by day more efficient. But what is not getting more efficient is the way we are moving the code from our local IDE to the respective environments in a consistent and secure and scalable fashion. That is the opportunity where the platform generic tries to unblock. The platform focused exclusively in automating this 79% block. That's where the business objective transforms into value efficiency. How do we measure that? We used to measure about number of lines of code or number of environments we have provisioned and number of commits, number of pull requests. But from the overall side, the shift is happening as a DX score for. And the first one is the speed. What is the system level delivery? The DORA metrics are like deployment frequency, right? What are the system level delivery we are doing at what pace? And then second is the effectiveness. How do we remove frictions when we are delivering this? It's about the feedback loop and flow states. And then third is about the quality part. How the system reliability and code health pivots to the importance of quality. Every aspect of the overall information systems are moving towards the quality aspect, because without quality you will not sustain it. And then the last one is business impact. How quickly you are bridging the capabilities to the revenue and time to market. So GTM. So the elite organizations actually move past the measurements from number of pull requests, lines of code and commits to pairing with quantitative deliverable metrics, whether it is a space or a DORA, with a qualitative DevX service. So that's where the shift is. And this is the outcome of how the overall platform space is there. You have an abstracted infrastructure called orchestrator, which helps you to provision the environment in a very sophisticated and secure way. And you have an automated governance and security in terms of policy bots, which helps you to drive the contours. And when we mix these two and then provide it, the IDP, internal developer platforms, is transforming slowly into agentic development platforms, ADPs, right? And it also funnels with the unit economics, which is nothing but our FinOps or token economics. So the clear dual mandate or an insight, what I would like to place in front of you is a platform built perfectly to abstract complexity for the human developers is the exact prerequisite of operating system required to host or govern or scale autonomous AI agents safely in the enterprises. So the days to come, you will see more the IDPs seamlessly transforming into the ADPs. And okay, we have now ADPs into the picture, but how do we balance those four aspects to it? One is an empowered mini platform teams, how it operates in a federated model. You have a centralized platform teams, which is having a shared protocols, automated governance and a code mechanism, which takes care of security, vulnerability remediation, compliance check embedded into their CI/CD pipelines, powering the mini platform teams across various domains in the overall business area and try to provide that. So there will be a central core one, and there will be small mini satellites which will be helping and then orienting ourselves with the centralized one. This is the thing. So the scale operations across diverse business units safely without sacrificing the development velocity. So that's how the overall industry is drifted as a federated model. And here is the 5 key pointers which we would like to leave from a platform engineering perspective. It becomes as a strategic investment now. That's what the measurement of 10-15% in terms of DX score for. And it's becoming more business objective focused. The reason of the business objective focused is when the business wants a feature, they want it in a scale, secure, and in the production at a fastest time. So how platform can reduce that 79% gap? So that's where business objective focused. And it also gets into the voluntary adoption part. The moment we call the platform engineering, so you are going through a self-service and agentic way of helping the teams, developers to move their code to the respective environment. So voluntary adoption is one of the strategic mission for platform engineers, and not to ask developers or the teams to onboard by force. It is the features of what you serve which will help them to onboard on them. So it's a self-service and then automated capabilities. So that has to drive. And then NPS motivated. So we will measure the actual value created by platform engineers, not by something like some number of how many pipeline runs it has come, how many services you have deployed, how many tickets they have done, and then how much within the time work. It will be through the net promoter survey. The net promoter survey, it's a very simple thing. If you go to Decathlon, after you pay the thing, there will be one screen will come, right? Thumbs up, thumbs down. So when you say thumbs down, people immediately come and then say that, hey, what else did you do? What made you to feel different? That is the mindset. That's called net promoter survey mindset. When you run a pipeline or when we provision a service, what is that feedback they are giving on the moment? How do we capture that and then complete the feedback loop? That's the typical mindset of the NPS and FAS. FAS is a feedback action score. And then the last one is MVP driven. So minimum viable platform driven. So it's the days are gone. We are all very well known. The huge projects with running into 6 months, 1 year and all. Even a huge mainframe transformation, it happens in chunks in terms of isolated small services, and then see the quick developments and then the value from the business. So it's an MVP driven, and it's not just from the development area and also from the platform area. And then this is the last one. Without active executive sponsorship and product discipline, platforms degrade into an expensive monument to engineering excellence. So this is the sort of fact statement. So with that, I will just hand over back to Raghav for taking it to the next. Thank you. Maybe if there are any questions, I would love to answer. If I know, thanks for. Just a moment. Yeah, the first session of this day is to cover the self-service aspects and to go from tickets to autopilot and going to tickets. Let me invite Deepak to the stage. Thank you. Hey everyone, thanks for coming here. I'm Deepak from Platform History Team. For the next 25 minutes, I'm going to talk about a process that every of our platform engineers have gone through it, and
And we know a process of how painful it is onboarding an application manually, getting. So when I say onboarding, it is nothing but when an application team wants to develop their applications, they want to integrate within your platform team, getting your CI/CD provisions, getting your security aspects embedded into it, and then it will boost your productivity, right? You're starting your CI/CD, and then you'll have to take it from your IDP, so I mean your local development to production environment. So how are we going to automate it? This is what this session is about. So from tickets to autopilot, let's get into it. So imagine this, as a platform engineering team, everyone would have gone through it. If you start your day, it's a Monday morning, and you start receiving your tickets on someone is asking, hey, onboard my application into OpenShift. So you know the drill. There's no process. You have to create a repository to set up your pipelines, you have to integrate security into it, it gets into your Helm, your Argo CD, you're going to set up your monitoring aspects to it, you start working on it. Meanwhile, you're working, you receive another ticket where someone else is asking, hey, I want to onboard my payment application into cloud. Again, you know the steps. When you're already working on another request, you receive another one. It's just another same repetitive steps, but for a different application. When you're working on this, you receive another ticket because someone's team is saying, hey, my pods is not coming up, pod is hitting the image pullback issue. So now we are getting into a firefighting situation for someone else's configuration. See, you could all imagine this, because every platform has lived this situation, right? The problem is the solution isn't hard. It is just how we are going to automate this. Because until unless you automate things, it is going to be very repetitive, manual, and unscalable, right? And you think when someone raises a ticket, they're going to say idle? Definitely not. They're also going to chase you up. They're going to ping you in Teams. They're going to follow you up, asking, "Hey, is it done? I'm waiting for you from last 3 days. I'm facing issues." So the problem is when you're trying to do things repetitive, it is going to get into misconfigurations because humans tend to do mistakes. When you're trying to do the same thing 100 times, definitely you're going to do a mistake, right? So as a team, we sat and then we took a break and then we think about it. How can we automate this? This is what we thought. What if what if a developer can get everything that they need under less than 30 minutes raising a ticket? What if you could automate all these things? This is what we thought. Instead of thinking, what if you could hire more people? Or what if you could create more runbows? Because that isn't going to solve the problem, right? So this is how it used to be earlier, right? Teams used to raise a request. There was endless follow-ups. There was a lot of coordination required between multiple teams. And developers used to wait until unless the platform engineer completes the request and make it available for the platform and developers to start working on the things. And if there is any misconfigurations, you are going to get into chaos, right? Definitely, every developer, every request that they raise, it is important to them, it is critical to them, and it is urgent to them. Okay, right? After automating these things into self-service, you don't have to raise any tickets. There is no coordination required. Everything is getting provisioned in less than 30 minutes, and it is going to be 100% accuracy. Because this is driven through a self-service automated flow, there is no chance for errors here. Every service is going to get the same set of pipelines. Every service is going to get the same set of security configurations done, and every service is going to have the same. There is no drift, right? You are not going to hear these concerns. So now let's try to get into a little more details, right? So how we are going to segregate this? First one is layer one. Consider this as your mental model. Layer one is nothing but your interface. IDP, you all know, like Pala said, right? This is internal developer portal. So consider this as your backstage. This is a sort of interface where every developer can just come, view, submit a form, and then things get provisioned. They don't even have to know what's happening in the behind. That's how simple we're trying to make it, right? So we have done and we have utilized Red Hat Developer Hub as a IDP tool, and we have a lot of plugins and we have posted on IDP. Okay. Second thing is layer two is nothing but your brain. This is what we call as orchestration engine, which we call it DevKit. Okay. This is built using fast API paired with G2 templates. Okay. What this is going to do? The information the developer is submitting in the IDP, which is your UI, right? All this information will be extracted
And based upon the information that you have provided and the tools that you have chosen, everything gets provisioned, orchestrated by this template. And it will be made available for your developers within less than 30 minutes. Layer 3 is nothing but your muscles. So what we're going to do here is we're going to add integrated 7+ systems here. When I say system, it's all the tools. You might have heard about all these tools, you might have worked upon half of this, or probably would have ended up working on all of this. The value isn't in the tools. The value is in how we're going to integrate all these together and create a self-service automated workflow that gets your job done quickly. Right? You might have heard all this with GitHub, OpenShift, Argo-CD, Tecton, Terraform, Google Cloud, Quality Gates. Nothing is new here. Just watch this. This is what developer is going to see, right? There is no hassle for them. They don't have to remember any YAMLs, they don't have to remember about Terraform codes or modules, no customizations or no configurations that they have to remember. They just have to come to your UI and then submit the basic information that they already know, right? Like what type of your application it is. Is it a front end or a back end? It's a, what is your application name, service name? What tech stack is it? Is it a Node.js or Next.js or your Python or your Java, whatever it is, right? And then you have to select what type of branching strategy you want to go with. You have GitHub flow, which is trunk-based, multi-module, multi-branch, which we call as git flow, and there is another called as promotion-based, where you're going to promote artifacts from your load from to production. Because application teams are very sensitive over the practice that they are following, right? And next, you want to choose what deployment type it is. Where you want to deploy your application. You want to deploy it on cache, which is your OpenShift or Kubernetes, or you want to deploy it in any of your cloud native services like Cloud Run or ECS, AWS, right? You want to choose this, and you want to select what all environments you want, right? QA, stage, prod. And then you're going to select the quality gates like Sonata, Fusa, Checkmarks, or Cyclone. And if you want any additional pipelines to do your end-to-end lessons like Playwright, Hopscotch, Human, you're going to select all these information and just hit submit. So once you hit submit button, the orchestration engine is going to do everything for you. So all you have to go to do is remember the basic information that you want and hit a submit button. In the backend, automation engine, orchestration engine is going to promise everything for you. You should be good after 30 minutes to start the development. Now let's deep dive more. How did we segregate this into 3 phases, right? Segregation and planning of these 3 phases is critical to everything, right? So first thing is phase 1, reason considering our requirements and business use cases, what we are using is okay, creating namespaces is the first thing thing for us because we are laying our pipelines in Tecton, right? So first we are going to create the namespace in the Tecton to provision our pipelines, and the application team wants to deploy their applications in OpenShift. We definitely need OpenShift namespaces created based upon the environments that they have chosen. And also, when they choose and submit the onboarding form, right, a lot of PRs will get raised in the respective repository, and the PRs will be reviewed, approved, and also merged by the boards automatically. There is no manual intervention in this entire loop. So phase 2, this is onboarding tasks. So this is the orchestration engine I was talking about. This is going to do a heavy lifting for you. I'll go through each one of them, right? First one is GitHub repo. So an application team chooses the service that they want to create it, right? So it's going to create a repo for you. This is not just an empty repo. You're going to have scaffoldings as well. Let's say when I say scaffoldings, it's going to have your boilerplate code, which is just a sort of hello world, right? And we are going to integrate all the pipeline scaffoldings based on the inputs that you have provided in the self-service platform UI, right? And we're going to integrate it with merge view, rule sets, policy boards, status checks, GitHub teams. All these things are integrated in the repository. Second thing is Argo-CD pipeline scaffolding. So we are using Argo-CD heavily here. So we are going to create an Argo-CD application which is going to manage your service accounts, your secrets, your config maps, all these things, which is required for your applications, pipelines to communicate from your Tecton cluster to your OpenShift cluster or to your GCP projects. Third one is property management. So this is ME authorized with embedded to Helm charts. So what we are going to do here is based upon the number of environments that application team have chosen, right there, previous stage and prod, you're going to create Argo-CD applications and where you're going to manage all your infrastructure and application specific configurations. This is one place where you can do everything. You manage all your configurations at this place. Fourth one is something which your GitOps suite. So here we are going to sync all your secrets, the reloader and service accounts and something with respect to your authentication for pulling the images from artifact registry. And then comes pipeline templates for it. We are into pack. When we say pack, it is pipelines as a code, right? So we are going to give your CI, CD, merge, conflicts, merge list pipelines embedded into your repository. And then nothing last is nothing but your quality gates. So we are going to enclose all your Slack, your your site code, all things are propagated in the repository. Third one is infrastructure as a code. Since the phase one is prerequisites, once the prerequisites is completed, phase two and phase three can run in parallel. As part of phase three, what we are going to do is we are going to create all your Terraform resources. So we are going to create your service accounts, we are going to create your artifact registry, we are going to do your web bindings, we are going to create your secrets in your GSM, right, in Google. So this is how overall automation is going to look like. Once the developer submits his form as part of prerequisites, we are going to create all the namespaces in your techno cluster, and this is your app workloads. And then IAC, as part of IAC, as I said, we're going to create service accounts, artifact registry with bindings and secretization. And this is the heavy lifting setup that I said. It's going to create your repo, Argo City, GitHub Shopper Manager, GitHub Suite, and so on. So under less than 30 minutes, application team will be able to start their development. You don't have to wait for anything else to be done. Everything is configured and ready to use. All they have to do is, after 30 minutes, they'll be able to just raise a PR, the CI trigger, which will do your build, test, and then push your image to artifact registry. And within the next 5 minutes, you'll be able to deploy a Hello World application into the deployment platform that you have chosen. And this is something that is very important, right? So as you all know, one t-shirt size can't fit to everyone. So our developer teams are very sensitive about, they have a very strong opinion about their branching strategy. You cannot force everyone to get into one single branching strategy. So instead, we ask them to choose the one that you're very comfortable with. So first one is your GitHub flow, which we also call it as track-based development. Second one is Git flow, which is nothing but your multi-view branch. And third one is GitHub flow promotion-based. So we have created and procured 3 different solutions that is heavily integrated into our self-service module. Application teams just need to choose the one that they want to get into it, and the orchestrated engine is going to get everything configured for you the same way, irrespective of the flow that they have chosen. So this is something which is very interesting, right? No one will get to know what's happening in the behind. As I said, 5 to 10 PRs will be raised into multiple repositories, and all these PRs will be reviewed by a bot, it will be approved by a bot, and it will also be merged by a bot. We don't even know what's happening in the behind, but within less than 2-3 minutes, we'll have all these things. As I said, PRs will be open, it will be approved, it will be, once the policy bot is satisfied, another bot is going to merge your PR, and your repository is going to sync things. And once obviously is synced, your configuration is going to reflect in your repository. That's how quick it is, which you don't even know what's happening in the behind. Even before you're thinking, things would have been propagated in your repository. Enough of the slides, let's get something into action, right? It's a quick demo that I've recorded. This is a self-service tool that we have built for food, right? So you're going to select your type of application, what is your service name, you're going to select your branching strategy, you're going to say what it is commit-based or promotion-based, you're going to give your access group to get your access things sorted for you, you're going to select the tech stack, you're going to select the teams that will be associated with your Git repository so that if you need approvals for promoting things. And this is the Sonar Cube. You're going to input your Sonar Cube project key. You're going to input your COSA project. If you don't have a project, you can also create these projects on the fly. And you're going to select all your environments like QA, stage, and draw. You're going to select the deployment type, where you want it in OpenShift or in Cloud Run. And you're going to select it's a continuous delivery or continuous deployment. And you're going to select that you want to go with blue-green option. And then the next step is something about you're going to select if you want any additional pipelines like Playwright, HubSpot, Human. This you're going to submit it. Once you have submitted it, this is how the submitted form is going to look like. Okay, once it is completed, this is how you're going to see. If you see that it got completed in less than 12 minutes, right? This is a request configuration that team has submitted. This is the prerequisites pair, which is creating the namespaces in Tecton and App Cluster. This is the IAC resources, a lot of PRs were raised and it was automatically merged. And then this is the heavy lifting phase I was always talking about, Argo City, GitHub Suite, the disabling webhooks, and then the repository configuration with all the scaffoldings. Okay, let me also take you to the repository and show you what all is getting automated, right? This is the repository that got created, and this is the pipeline configuration that got embedded into it with all the configurations that they have chosen. So if you see here, for stage and prod, application team has chosen to enable blue green, it is already enabled for them. Along with this is the scaffolding that I said. This is the R2 city values, N values that is getting propagated in the repository based upon the environments that they have chosen. And let me also show you the branch protection rules, the rule sets, the custom properties that we are going to get configured in this repository. So if you see this, they're going to have one branch called as main, and within this branch protection rule for main is set along with all the status checks. And you're going to see a lot of rule sets created. We are enabling merge queues for them. You're going to create a separate rule set for hotfix. You're going to see a lot of custom properties that are configured for this application. And this is the interesting part. Okay, there's another thing called as started. We said you right, we are into pack. So pipelines as a code. Application team will see all these pipelines also provisioned in the repository. And this is the interesting thing. Argo City application getting created. If you see this PR was a bot and it is approved by a bot and it will also be merged by a bot. And this is the second repository which I said, the property management repository. Based on the application team's selection for environments, all the obviously applications are created where you're going to manage your application specific and infra specific configurations. All these PRs are getting reviewed and merged by the bots. There is no manual intervention here. And this is nothing but your third repository where we're going to create GitHub suite. So this GitHub suite is nothing but it's going to manage your secrets in handler, your artifact registry secrets, and also your keyless servers. All these things is managed by this third repository. So this is how all these things got completed. One plus three resources are provisioned under 30 minutes. If you see this example, it got completed in less than 12 minutes. So development teams will be able to start their development within less than 30 minutes, right? Once you just submit the form, it's going to take a minute or two for you with all the basic information that you already know. And once you hit on submit, you'll be able to get this thing configured in less than 30 minutes and you're going to start developing your application. We are not going to stop at this place, right? There's something called as marketplace as well. So this marketplace is a place where we are going to, on a weekly basis or on a monthly basis, we are going to introduce a lot of new features. Because application team might choose something basic in the initial things and they want to set up more. It hasn't been introduced to new things, right? So you can come here and you can select any of this and you can get it integrated. You just have to come here and say, hey, I want Cucumber pipelines to be integrated in my repository. Just select this, select your repo, click on submit. It will be configured in the backend. So similarly, there was a lot of things that are going to get integrated here. JMeter, Human, Hopscotch, Potato Crunch. What all services that we have and we are serving through self-service, everything is available here as an individual service. Basically, you can call it as standalone service. It's just like your Play Store or your App Store. You can come, take, choose, and get it configured for you. This is a quick number game, right? So, as I said, I keep on saying so many times that we're going to complete this in 30 minutes. There is no tickets filed here. You don't have to raise any tickets. There is no manual handoffs. 12 resources are created, and there are 7 tools we are integrating here, and 5 to 10 PRs that are automatically raised, merged. And as you all know, onboarding is A1. We are not going to stop it here. Once you have onboarded, we also want to monitor, right? We want to see how our services is performing. We want to get the real metrics of it. And also, we want to get how it is performing like NPS and NPS, right? Net Promoter Survey and Feedback Action Score. So we have also built something called as PPMF, which we call it as Pipeline Performance Measurement Framework. So there we have created a lot of dashboards, which is going to give you a real-time data, how your pipelines are performing, what is your success rate, what is your failure rate, what is your SLA, how many pipelines are failing because of development issues, how many pipelines are failing because of your infra issues. You're going to get a detailed report on a timely basis, right? And then so this act is nothing but Net Promoter Survey. On every pipeline that you're going to comment on a PR, asking the feedback of the application team to understand their pain points. We need to know what's happening from there, right? We would have thought about 100 plus use cases, but the application team wants some more else, right? So we have to comment on the PR and try to get their feedback. Once we receive a feedback, we are also going to analyze within our team and see if it's a valid one. If it's a valid one, we are going to put it into a backlog, we are going to start working on it, we are going to roll it out. That's how this entire thing is, right? Onboarding is stable, but this loop is never going to end. Okay, this is a sort of culture shift, right? Earlier, we are all like a ticket processor, ticket rituals, we used to start working on it. Now, we are turning towards into a product engineers. We stopped fulfilling requests and we started building capabilities as a product, self-service products. So this is again, there is no magic here. You all know all these tools. There is nothing new here. As I said, the value isn't in the tools. The value is in how we are going to orchestrate all these tools to together build an automated solution which will get your workflow done within a couple of minutes without a manual intervention. Now, okay, these are the three things that I would like to give you that you can carry to your home, right? So treat your platform as a product. So you need to consider your developers are your real customers. You know to get the real user experience. Once you have a clear roadmap, your features are defined. Automatically, tickets are going to vanish from your queue, and you don't have to build new tools. You just have to integrate all them together to get your work done. And self-service is a philosophy, not a feature, right? So how many manual hands-off you're going to eliminate, those many tickets are going to vanish from your queue. Now, as of today, we stand here where we are going to developers are going to submit a form that will automate everything for you. But what next? Next is all about AI agents, right? Where you don't even have to submit a form, you just have to go there and say in your natural language, NLP we call it, right? You just say, hey, I want this. The agent is going to do that work for you. That is what we are looking at for tomorrow. Thank you, everyone. It's time for the questions.
So these are this side. Okay. So first question is like you mentioned platform, end-to-end platform. So we have integrated security related sonar loop for static code analysis. Since so you can make use of you have capabilities in GitHub itself, right? So while you are integrating separate tool.
So what sort of capabilities?
In GitHub, we have GitHub depends upon.
See, these sort of things are all organization driven, right? It's an organization decision. If organization wants to go with the tools, we just have to comply with it, right? It depends. It is not a mandate for you. That's true.
Suggestion for you. So why you add extra tools and extra money, so you can make it clean.
It's again, it's an organization decision. You have to go by.
You actually answered it. I'm not trying to convince, but all these tools have come into this in a different phases, and probably there may be a time where things will get much more integrated and harmonious. But at this moment, we have to live in such a situation with all these enterprise architecture. We still need to automate things. I'll tell you a simple metric which transformed. Earlier, we used to take around 3 weeks maximum for laying a pipeline. After the self-service, typically within the matter of around 2 months, the onboarding had transformed to we have onboarded somewhere 350, and in that it's all development production tested around 200 within just 2 months. It is almost more than 10 pipelines per day of things. Right? Earlier, not even one we could do it in a day.
Just giving a suggestion and like mentioned like sonar loop, right? So how we are doing like third party vulnerability scans when you work on applications like Java front-end applications, right? How we are doing third party vulnerability scans.
You have FOSA, right?
I have not seen.
Yeah. You have SonarQube, FOSA, and Cycode.
Any framework you have and your
So it depends upon the tech stack, right, and the application team wants to do. So we have provisioning all the tools, all the other tech stacks that the team is wanting, right? Like Cucumber, your Playwright, your Newman, your Hopscotch, your Rest Assured, all these things are integrated, including your Playwright.
But those are the tools you are integrating to your CAC or
Yes.
platform, right?
Yes.
So is there any framework that is also integrating part of that self-service? Like say I want to do regression suit end-to-end or
Yes.
reconciliation.
Yes.
I mean, you're just provisioning the platform
Yes. Yes. Right. So what they do is they deploy the latest release revision, and once a new tag is deployed, they want to run their automated test cases using hopscotch or human or whatever it is, right? So it is automatically running your test cases, and once the hopscotch is passed, then only it will create a new revision of nodes, switching the traffic, and is going to reduce your other pods. So that's how it is implemented.
What I'm saying is like, so we have, I mean, read all of these things, load testing, performance testing, all of this framework. So more than that, like the regression, so API testing. So no need to write anything on the framework level. Just they need to write the scripts and paste it in the GitHub repository.
That's what is going on now.
Yeah.
Right. There's a dedicated team led by Ravi for platform performance testing. Like you want to hear next session from Ravi.
One thing is like once, like if anyone onboarded to your product, right? So let's say using self-service portal. So any new versions, right? New release. So how it is going to sync to their repositories?
It is again with us, right? We have a custom automated solution. As and when we release a new version, it is automatically going to raise a PS to the application repo. Application team can choose what is the feature that they want to benefit. If they want, they can merge the PR and pull the latest changes. Thanks. Thank you.
How do you ensure that architecture is related to security? For example, an architecture, for example, you have different products and different products need to be used by different users, right? Or user groups as such. So they are, certain users are confined to certain level of usability and they should not club with other users. Is there any architecturally you have any security where you confine the certain developments to certain domains and add security to that layer?
All these are managed by working groups, right? And also everything is an isolated namespace. We are heavily into Kubernetes, right? So every application is going to have its own dedicated namespace, and only the respective team will have access to the namespace. It is all managed through RBAC, role-based access control. So you will not be able to see what's doing by some other else.
So the roles are defined at the earlier stage.
Yes, they will have access roles created, and in the onboarding form, they're going to tell that this is the group that I want to associate with this application. So people who are part of that access control group will be able to access these resources, no one else.
And how this will be restricted the role-based access and other things in your security or your testing? And testing is all done through the pipeline and your automated layer.
Mhm.
But when it comes to these functionalities, how the AI or other things will take care of this testing?
What sort of cross
For
functionalities?
example, if you told about the isolation of the roles and
Namespace. Mhm.
so when the traffic flows into the real network, right? So it can have collision with other.
It cannot. In Kubernetes terms, right, this is an isolated environment. So each namespace is going to have its own resource quota. So you can bump it based upon the usage, right? No one can enter the space. This is going to be like a dedicated room for you.
And if they have the enter, you have to configure the ingress. Without that, things will.
That is for external access.
To add to that, right, I think your question is more of how the testing works as such, right? Once the pipeline is also, see, once the setup is done, pretty much, after that it is more for the teams to generate their own suits. And when it runs through the cross-functional services as such, if the functionality is working fine, then the requirement will be passed and the infrastructure will provision access, right? And the traffic will be diverted. Otherwise, it will not. So they will have some thresholds set for each of the testing that is being done. And that runs via the pipeline is the final hold would be from the product teams themselves.
So, as a developer, first time that I'm doing it, I have a control and for testing purpose, I just wrote the security or control layer.
Now we cannot do that.
So, okay. So,
Once you are into it, all these things are gone in. Right? So
But still, you can play in the dev environment, but not once you reach the stage or pre-prod or prod, it will not allow. The policy will stop.
any more questions?
Yeah. So what is the failure scenario? What are you in the system capacity available? What happens when you have capacity still? Are you going to ask people to start it? How do you control that?
So, see, as I said, it's been like 3 months since we are serving this, and it is open to all the application teams in MS Tech level, right? So we also face a lot of failures. We are not saying that we are consistent from day one. So we are improving upon it. We are getting the feedbacks and we are setting things up, and we have a lot of backlogs to work on.
I'm asking, is your system capacity available? Do you know in advance before I start promising this?
So we have done heavily integrated testing, right? We have done a performance testing as well, where if a team will be able to submit 10 onboarding requests at a time, is our platform able to scale it? We have tested it and we have proven it, and that's where we able to do application teams.
My question is your piece of tool aware of the capacity at that point of time?
So how do
Yes.
how do you know the amount of
Yes.
scale?
Yes, we do. Yes, we know.
Go from the beginning.
It is actually capacitated towards the number of, we have the overall inventory and then we have retrofitted our overall scaling part of it. But again, you have to still platform. The moment it is the individual namespace which is running pipeline, it should be working. There is no constraints on it, and there is ample of capacity in terms of CPU memory and the size of the memory factor.
Because you have so many indicators, right? One is Kubernetes. Have other tools. Maybe you run out of some licenses, some tools which are using. At that point, you never know. For example, Solar. There's a license. Are you self-aware of that?
He nicely pointed out in that there are failures. It's not that this doesn't happen with that. Even yesterday there was an interesting issue we were trying to solve out. It was a simple password explaining, but somehow it missed our overall thing and then do. So like
I do, but if it fails, it starts from there.
Yes, we do have a return mechanism here. Even with this retry, if it will go forward, it is going to intimate any of our platform engineers with a notification saying that, hey, your onboarding is failed, and take a look.
please do connect with us offline as well so we can share more. Definitely. It's not foolproof to the any system cannot be 100% foolproof, but it's a continuous iteration on improvement.
Anything else from anyone?
Bhaskar.
Thank you.
Okay, we'll wait. We'll go for a break, and then. Oh yeah, let's come. Deepak, can I invite Ratna to give us small speaker memento to Deepak? Can you capture this moment? Can you capture one?
Thank you, Deepak, for the wonderful session.
Yeah, we will have a short break, please.
One first session. To start like 10:30.
start in 2 minutes. Yeah, thanks everyone. We'll get started the second session. So the second session is about from DB to DOM to AI. Yeah, this will be covered by Ravi. I will try. Thanks, Ravi.
Thank you. Hey, good morning, everyone. I'm Praveen. I'm leading the performance engineering space in Info. So today's topic, I would want to touch upon kind of my journey. I would put it that way because the experience that I had in the past and the present, and probably will be the future as well. I believe is based on all these different worlds. So these are the four worlds that we are going to talk about. How performance engineering is one discipline, and we have four different execution worlds, and where it all fits into one user experience. So that is the gist of this particular presentation. Go to next slide, please. So the bottleneck always keeps moving in terms of performance engineering. It doesn't stay at one place, right? So in the older days, or even for that matter today, we still ask if my DB query is performant, right? Am I adding my indexes properly? And we are still holding DB responsible in some cases if my application is slow. And the DB is tuned, I move to the next place where I come to the application layer. Do I have a defined capacity? Have I made sure I have my thread pools, everything set up properly? Do I have my guardrails properly set up? And so on and so forth. And we are in a rush to fine tune our application. Even if you make your APIs faster, that doesn't mean that the user experience is all fast, right? User experience also has its own sets of nuances that we'll have to take care of. Fast API, it doesn't mean that the user experience is also blazing fast. Right? So, can the user feel the fastness that you have done, the tuning that you have done? So that is on the DOM world. The last, so currently anything and everything we search via AI. Gone are the days where we were doing a Google search, going to each of the Stack Overflows, copy paste, done. Those days are done, right? Anything and everything we are getting it via AI. Now, can we afford the compute? Now, there are folks who kind of, put forth about 30, 40 documents, ask it to analyze and tell me like what's going on, right? Now, the compute behind it is going to cost millions. Okay, so that's the touch upon is I mean, are we in a position to afford the AI? Okay. So considering the different metrics and the different tools that we use to evaluate each of these words, but the engineering loop is going to still remain the same. Where we have to first define each of our SLOs, thresholds, and so on and so forth, and then we have to instrument what is needed in terms of what are the metrics that I need to kind of look at, the traceability that I have from end to end, starting from my request, where I make a request till it reaches AI and comes back, I have to have a traceability matrix. And then the model that I use in terms of model again doesn't mean your ChatGPT or GPTs and Geminis and so on and so forth. This is more of how do I workload similar to a production, like how do I simulate a traffic of that pattern, and then we have to experiment with various parameters, right? And then we'll have to verify whether this actually helps us in terms of both performance. So when I say performance, in terms of response times, right? As well as the required throughput, am I able to achieve it or not? And finally, the guardrails, meaning if my request is failing for some reason, there is some slowness that we see from one of the layers. Am I having a timeout sequence or not? Am I failing it gracefully? So on and so forth. So those sorts of guardrails is what we'll kind of touch upon. So this one will talk about it post the session as well, meaning post all the session is done. We'll have one more slide where we will kind of see a repetition of the same, and we'll try to connect the dots at the end of the session. Next. So performance is always an end-to-end budget. It is not one single component, right? You have to make sure the DB is fast, your application is fast, meaning when it's application API is fast, and then your front end is also in the same way. And when you use AI, how quickly are we reacting to the prompt that is coming out? So as part of this, you'll always have to budget your critical path, right? You have to make sure you have defined your latencies, defined your thresholds, defined your SLOs, and so on and so forth. And averages are always a lie. You never have to go with averages. In case of your APIs, you always have to look at your P99s and make your system working for your P99s. And if it is from front-end perspective, probably the 75th percentile. Now, why 75th? We'll touch upon that topic again when we go to that particular slide. Okay, and user perception is more important than what we are achieving individually. Right? When a user experience is slow, how much ever fast you build an API doesn't help anybody. Right? So we have to make sure the perceived performance is great. Only then the application or the page will be identified as a highly performant page or an application. And last but not least, every synchronous hop spends latency budget, and then you have the reliability budget also, where you will have a lot to spend on it. So the first word, the database. I think everybody would have faced this issue at least once in your lifetime, right? Where my query is very slow. Right? So the general bottleneck that we usually identify, probably build an index. To create an index, things will be fast. But that's not the only place to look at. This is one classic example that I would want to go through. Again, there will be some war stories that my experience, I mean, in my experience, I had some of them, so I would like to share those as well. So, same thing, when we try to do a nightly job, right? The nightly job took about close to 6 hours, right? And the nightly job is basically to update certain records on a PostgreSQL. And then, suddenly the timely job, the nightly job took a long time, right, for completion. So when we went and looked at the query insights will tell you, this is the query that has taken more time. It will not give you the reasons why. Probably when you go to the update, it will tell you like, okay, this is the cost spent on it. Or if there is a select before the update, it will tell you, okay, select has taken so much time. Now when you go to the individual queries and run the execution plan against it in your lower environments, it will always say, it's very fast, I mean, costs are very small, right? But the catch here is, when we go to the particular tables, take the statistics of each of the tables, we found a bloating. Right? Now, because there were a lot of updates and deletes that were happening on particular tables on Postgres, and I believe most of them would agree like or understand how Postgres works, right? So because of its multi-version concurrency control, it will not delete the row directly when you do an update. It will create a version, it will mark the older version as a dead tuple. Okay, and then there will be a vacuum job that runs and then clears the dead tuples. This is how it works. So when there are a lot of updates happening or a lot of deletes happening, there is a good chance that the auto vacuum is not able to clear it and the table can become bloated. Alright. Now when a table becomes bloated, the PostgreSQL query, so it basically can check whether I have to do an index scanning or sequential scanning. So it does a cost estimation by itself, right? Though you create an index, if it feels the index scanning is going to be very costly for me, it will switch to sequential scanning. Now the problem that happened for us was, because there was about 1.8 million records of dead tuples, the Postgres had to choose a sequential scan because index scanning was, costlier, and it had to go through each record to just fetch only one. So at the end of the day, though it says your query was very slow, this was more of a maintenance problem than anything else on the tables, right?
So we had to manually go run the vacuum analyze to clear those dead tuples, and then post that we had to fine tune some of the auto vacuum related parameters, like something like thresholds and the scaling factor. So basically, this is to say that if my 20% or 10%, whatever value the scale factor that you decide, and say like, okay, this is the number that I give. So if 10% of dead tuples are available in the table compared to live ones, it gets cleared automatically. So we had to fine tune some of the parameters, and finally we were able to fix it, right? And whatever job was running 6 hours came down to about 20-30 minutes. So that was a change that had happened. And again, when somebody sees from outside, this looks like a query problem, but whereas it is more of a maintenance problem, right? So this is how performance engineering is all about. And then the other ones, as you know, the N plus one, ideally this is not something anybody would encourage, to have a sequential calling of your queries again and again to update or select any records. So this is something that we generally don't want anybody to do. And same way, the scanning and splitting, make sure you are actually pulling out records what exactly is needed. And this is very particular or very evident with the API users as well now. If you are going to display only certain parameters on your screen, you really don't want to get the complete information out of your records, right? So ensure what is required, and then your databases or columns accordingly, create an index as needed, and then maintenance is all great. So the database, probably we have tuned it well. So database is blazing fast, the queries are all working fine. Now we are coming to the application layer. Now application layer has its own challenges, right? When it comes to application layer, your capacity, the way you are making your API calls, the external dependencies, if any, and so on and so forth, can impact your overall performance of your API. Now, this is one classic issue when it comes to a memory leak. So probably everybody would have come across a memory leak, right? Now, generally what we run an endurance run. So we see the memory growth, then we start taking a heap dump, then evaluate heap dump, and see what is in heap, then done, right? So we recommend certain things to the product teams. But the catch here is, if you look at the memory utilization, heap was all fine. We never had a problem with the heap, right? There is something called as off heap, right? Where we also call it as a native memory, right? The heap memory growth was hardly about 80 MB growth. So we are talking about only a 7% growth. The remaining 97 or 93% was with the native memory. So how do we come across, or how do we ensure to fix this native memory? Now heap dumps will not help, right? Now when you take a heap dump, it will just tell you like what is in the heap. So we'll have to further, we went further to understand what's happening, started getting the native memory related logs, trying to understand what is being held in the native memory. And again, native memory, if you all know, it contains your metaspace. So if you kind of understand your heap segments, so you have end, old, and the metaspace is something which was earlier called as Perngel, and before Java 8 it was all together. Now it is outside of heap. So that is part of your native memory. The other one, threads, stack memory. The stack memory is part of your native or off heap, right? And the other buffers or caches that you use, that is also off heap. So if you have to understand the behavior of all this, then you'll have to have a native memory tracking as part of your stack of parameters, right? And then we had to kind of explore those options, try to understand what's happening with the memory, and then we were able to identify something related to threads. The way threads, when you kind of invoke, it starts creating memory pockets. They call it as arenas. Okay, so once you start creating so many arenas, so the memory starts increasing. Basically, we call it as a residence exercise memory. So we had to restrict that, right? Instead of creating every time a new memory pocket, we'll try to reuse the particular arena that is already created. So we had to set a parameter called malloc arena max, and when setting that, so the utilization of RSS or the off heap memory that was there had come down to the way the heap memory was. Say for example, if your heap memory was about 200 MB, so we were seeing the RSS memory to be about somewhere around 250 to 300 MB. And whenever the heap grew, RSS grew along. It is not that RSS alone was growing, even though heap was all fine. So this is one setting. Again, native memory is very tricky. It is just one solution that actually helped us. But there are many things that we can look at when it comes to native memory. And in terms of API, when we do a testing, we make sure we model the load properly to start with, right? So that is the first thing that we'll have to do, where we follow something called as a Little's law, right? Where we kind of look at what is the TPS, what is the response time SLA, and then what would be the number of users that would be ideally required to run the particular scenario. So with this test is what we'll try to understand what the performance of the API is and where we can fine tune it, as well as decide the capacity. And capacity as well, it can be a horizontal capacity, it can be a vertical capacity as well. So in terms of horizontal, it is basically a number of pods, if it is a Kubernetes cluster, and on the vertical scaling, pretty much on your CPU and memory, like what would be the requests and limits and so on and so forth, right? So that is something we'll have to do in making sure that the APIs are working faster, right? And then you have to bound every resource, meaning ensure that your timeouts, circuit breakers, everything are in place. Now you cannot leave a thread open for a very long time because you have resource altogether, right? So you have to ensure you are having all the settings evaluated and set up during the performance runs, as well as any cold starts or any sorts of failover testing that we'll have to do. This is the place that you can do with the load. Okay, and then retries. So the timeout settings that you set should also have a retry as well along with the timeout, right? So the timeout should be inclusive of a retry. You cannot have a retry as a separate, right? So you have to ensure a graceful experience is given to a user. So that's the reason why we always say, even with the retry, the timeout should actually fit in, right? Now, the database is tuned, API we have made it faster with whatever is required. Now comes the front end, right? Now, both are fast. Now, doesn't mean that my front end is good. So there are some best practices that Google has defined, right? In case of how my user experience can look like. So they call it as LCP, which is the largest contentful paint, which should be less than 2.5 seconds. And then interaction to next paint, which should be less than 200 milliseconds. This is for your interactivity. And then for visual stability, we call something called as cumulative layout shift. So meaning, like if you open a page, the number of components it moves on the page, how good or bad it is. So visual stability would be measured accordingly. So that should be less than 0.1, right? Now, take this example. P99 response time of my API was too good, right? And I have followed all the possible best practices, meaning I reduced my bundle sizes, and then I have made sure, right, whatever scripts I need have been deferred and so on and so forth. But even then, customers are complaining my LCP is very slow, like it's almost like 4 seconds, 5 seconds, and so on and so forth, right? Now, from a front-end perspective, if the LCP element is an image, for example, right? Now, images always will be fetched with a low priority. That is a given. On a browser, your priority of any image that you load on a page is low, right? Now, if your LCP element is an image, you have to ensure you are prioritizing it. Now, if you take this example, you got your document very quickly, which is probably around maybe 200 milliseconds or so. There is a CSS file which you needed for styling. You have a font which loads your font stuffs. And there is a JavaScript which is needed for rendering. There is a sync library which probably could have been deferred, and then there is an API. It may or may not be needed, right? And then you have your main thread or the LCP image before that. So this becomes your LCP element. Now, because there are a lot of elements before the LCP image, the LCP scores have taken a hit. Right? Now you have to prioritize and make sure you add something like a parameter called a fetch priority on your images. Right? So once you add a fetch priority for your image and then you defer some of the scripts which are not needed, pretty much the front end can become faster. Right? We always have to ensure the main thread is unblocked. You cannot have tons of JavaScripts running and that will end up blocking, right? And ensure the stability is also maintained. Meaning you have to reserve spaces. So when you say that my image has to load here, you have to reserve a space for the image. Otherwise, your stability score will go and you will see components moving around here and there on the web page, which is not a good user experience. Okay. Next. So now comes the fourth word, which is AI, where we are in and where we are running. Right. So here, latency till the past, it was kind of at different layers. You knew where it was, right? But with AI coming into picture, there is a third constraint that has come into picture, which is quality. Now, nobody wants a worst answer for your question, right? The quality should be to that level, right? Now, when quality comes into picture, the way you are using your models, the way you are using your tools, everything will become a constraint, right? Now, the way latency works is at different levels. So once a user prompts, right, the model that you select, when I say model, it can be your LLM, you are making a call and trying to understand what the prompt is about. Now, if the response you know already, then you can provide it from your caching layers in itself if possible, right? Otherwise, it goes to the actual another LLM or an agent where there will be a pre-fill, meaning it will try to understand the complete context while pre-filling those tokens. Right? It will try to understand the complete context, and on the GPU side, it will try to decode the answers for each of them. And then, if the answers are not available, then it will go to the respective tools of the organizations that we have said. Say, for example, if I want a owner manual of one particular vehicle, now AI might not have that particular manual with it, so it has to reach one of the tools of Ford to kind of understand what my manual is about, and then it provides the details out, and it has to stream, right? Now, earlier, if you remember, when we started using AI, it used to come like a block, right? You prompt something, it used to come like a block. Now that latency is something, when you relate it to the user experience, it is a delayed user experience. Now nobody wants that. Now today's world, if you keep searching, it will tell you like I'm thinking, I'm reasoning, I'm doing this, that. So there will be a lot of prompts for us to kind of keep us engaged. So that is the change. Now when it comes to a streaming, when we talk about the user experience, there are certain things that have slightly changed when we use AI. Now, the time to first token has become our new LCP, meaning the first word that appears, how quickly does it appear? So that becomes our new LCP. So we want it to be quick, right? And inter-token latency. So between the words while it prints, like how long does it take for each of the words to come out? Right? And the end-to-end latency for the final output of the answer, how much time does it take, right? And we usually say, right, the fastest query is the one which never got executed. The same thing applies here as well. The fastest token is the one that has not got generated at all, meaning it is something from your local and which is deterministic in nature. And when it comes to AI, though we say it is all good, great, and all, it is still probabilistic in nature. That is the reason why, if we can say like, okay, if you need some deterministic approach, let's do it. Otherwise, let's try with AI. Next. So this was the one that I was talking about some time back. First thing, when you use AI, try to avoid. When I say avoid, if the answer that you require is deterministic, don't use it. Now, it doesn't need AI to run multiple the response back. It can just make a simple query and then get the response back on your balance details, right? So in those cases, it's no use to run with AI and stuff. So in those scenarios, you can very well avoid. Now, you need AI to give an answer. How do you route it? You cannot just go give it a Claude Opus and say, okay, give me the question, right? You have to understand the prompt and then route it to the appropriate model that is needed, right? And here is where I think we are progressing, where we have multi-agents, there is an orchestrator trying to understand the prompt, and then the results are coming accordingly, right? So choose your model accordingly, like to the standard that you expect, right? For certain questions, you really do not need Claude Opus to give you the answers. Now, for coding purpose, yes. For others, for a simple, clarification or something, you can very well use the other models like Llama and so on and so forth, right? So choose your model appropriately. Then reduce the token usage as much as possible. So for example, if the context is huge, try to say like, okay, this is. So if you see, probably like when you kind of chat, it will only tell you like so much of file size is only available for you. You cannot load more than certain limits. So those are all kind of to avoid or reduce the token usage, right? You cannot give a big prompt, otherwise it will take a hit on the utilizations. Wherever possible, do a reuse, meaning you have to make use of your caches that is available and make sure you have an invalidation strategy for your caching as well. And then once you are all sure that okay, this is what I would want, then you come to the hardware part. Depending upon the load, how much GPUs would I require, and so forth. What my infrastructure would look like. So that is where I would come as part of the last step. Before that, I have to ensure I'm all okay with what I get and what is the reusing strategy and so on and so forth that I have. All right. So finally, when this comes to the user perspective, now you as a user has asked a question, right? Now, how will it come from a UI perspective, right? Now, the prompts, after the prompts are done, it takes time for the response to come back where it tries to look for. So from API, it has made a call to get certain details, and then you're trying to data, and then you are trying to load it on the browser. Now, when it comes to the browser, the way the tokens come back, it is very. We are talking about 200 per second. Okay, 16 milliseconds, a repaint happens. So if you can fit in your batch sizes according to the frame rate, the animation frame rate, then you will not see a stutter when it comes to the prompts answer. So that is one practice that we can kind of take. So name is to say that as and when it comes, you kind of paint, repaint, and so on and so forth. So that way you are going to kill your browser. The browser will crash. Okay. So here is where your first token, when it lands, it is the perceived user experience, and the faster it is, the user will be happy about the overall experience of using our website or the tool that we have designed. Otherwise, probably that is what it is, right? And the same thing when it comes to visual stability, right? Now, let's say you have asked a question and there are about 1,000 lines that are getting printed, right? So instead of giving a scroll bar, nowadays it is getting auto scrolled. So that gives a better user experience than having the user to scroll down to the complete end, right? So that is one feature that is coming up to ensure there is a visual stability. And then same thing, guardrails apply everywhere, right? It is database or your API or your AI front end, your guardrails apply everywhere. So make sure you are bounding it, right? In terms of timeouts and the tools that we use to ensure that you're getting the relevant information. If not, give a graceful answer to the customer. So this is how a graceful degradation ladder can look like. When you are going on full agentic mode, right? It will give you the best quality. And then the problem with the best quality is you have the highest latency as well because it has to go through a lot of documents, and then it also creates highest costs, and then it can fail a lot because of the timeouts and other stuffs, right? Now, how do I come out of this? I route it to a smaller model to see if I can kind of compromise a little on my quality, right? Now, if my quality demands are met with a smaller model, I stick to the response and share it back. Now, the models have altogether failed me, right? Then I go to the deterministic response that I already have. For example, it's like a fallback, right? I can give back a simple answer saying like this is what it is, and probably the summary is not something, it will take some time and so on and so forth. Now, if the search is not working as well, then you can give a cached answer. But if that is also failing and it is kind of invalidated or it is a very old one, which doesn't make sense to give us back, then gracefully tell the customer that at present something is busy, will not be able to serve you at this point. So that is how we ideally have to make sure our application is responding to our customer's query. And like everything will have its own timeouts and things, and we have to ensure we are following it. Okay, I'll just go to the demo part of it. Just wanted to show you like how each of these words are adjusted in the. Just move the. Okay. It's a different. It's a different. Just a minute. Sorry about that.
Can you see the other side? Other side of this HDMI. Other side of the HDMI. Just remove it. Yeah, laptop is also.
So this is just a simulation again. This is something running in my local, so don't think it as a actual workload. Okay. So we are talking about the backend infra where everything is optimized, everything looks fine, right? Now let me just make a change where I have an inefficient DB query, right? As soon as I make a change, there is an increase in latency, and if you see here, the user experience is also going for a toss. So wherever I had a LCP of about, let's say 600, 800 milliseconds, has gone up to about close to 1 second now. So the backend can definitely impact front end, provided we have a dependency on a particular API, right? Now I have optimized my backend properly, completely. Now on the front end itself, let's say I have a huge JavaScript bundle. So as soon as the JavaScript bundle is introduced, my main thread is blocked and it is taking almost 2 seconds close to, right? And then my LCP scores, which was about 600, has gone up to about 1.4, 1.5-ish, right? So like that, fixing one layer doesn't mean that it automatically fixes on the other part, right? You will still have a problem, have to ensure the other part is also taken care of. Now, when it comes to AI, right? Now, let's take you're just giving a response back, like the naive streaming that we were talking about, right? You just start printing up the words as and when the tokens are coming in. So if you see the number of tokens that gets utilized, and if you see the compute that is going up, right? And based on that, the cost also will go high, and there is a good chance that your browser will crash, right? So the final takeaway, or how do we measure and all that, is still the same, where we define, instrument, model, experiment, verify, add the required guardrails, and the anti-patterns is something that we'll have to be sure we are not doing that. Just saying DB is slow doesn't help anybody nowadays, right? We'll have to see like why and what. And now the DB slowness is turned into model slowness. Anything and everything is on the model now, right? And average only dashboards is not something we have to go with. And then do not go with the happy path all the time. Happy path testing is probably the last one to look at. We have to ensure we are ready for the worst. Only then can our system sustain and then be available to the customers. And then, last but not least, performance work without verification is always a fantasy. And then the last slide for today, probably the takeaways for us. Always make sure you are tracing the journey and not the individual component. And bound every finite resource possible, meaning in terms of your thread pools, context windows, timeouts, and so on and so forth. And then build your degradation ladder in such a way that you are providing a graceful message to the customers. At the end of the day, customer experience is what drives us as well. That's all I had. Any questions?
First question was related to the post request. You talked about the dead tuples and how they are handled. So if post request has an intelligence to categorize something as a dead tuples, right? Why it cannot take it on the
Great question. So, if you remember a statement, if your auto vacuum is not able to kind of identify the way it is getting generated, say for example, your updates and deletes are quicker than it can actually clean up. So over a period of time, it starts bloating, right? And when you are not maintaining it properly, because once you're the way auto vacuum works again is based on these scale factors and the thresholds that you set. It will only trigger when it reaches that particular threshold to start with. And same thing for your scale factor as well. Until unless it reaches to that, let's say if you have set it at 20%, only if it reaches 20% of the live tuples that is already available in the particular table, only then the auto vacuum can trigger. And because you have so many updates happening on top of already what is needed to be cleaned up, so that is how it is.
one more question? You talked about this measurement. So tokens are something related to the internet to the LLM. So something related to the internet to the LLM, how it is categorized. How do you measure that inter-token latency?
Take the words, how it gets printed on your screen, the tokens that is coming in, right? Between
It's a response measurement.
yes. Yes.
Is DOM is something replacing somewhere? I understand that this is a distributed order object management or in that way, but why that name is gaining a lot of traction today? There are a lot of places DOM is used.
I do not have an answer actually, but that is something I can check and let you know. See, the way we are building up a page is all document object, right? The way we are building up a tree and then rendering it, right? And the way we are building up the tree is changing by the day. So earlier everything was client side. Now we are moving to server side and rendering the tree. And now there is also patching that you can do. There is a re-rendering that can happen and repainting that can happen. And also, maybe May would kind of help. So there is something called as virtual DOM. There is a virtual DOM as well, right? So it all depends on how you are rendering the page, right? And there are various strategies.
So, Praveen, you spoke about the performance today for this. Like now we are getting so many agentic AI applications, and there we don't know what is the SLA, right? Is it that as render in 5 seconds or 10 seconds? And developer would say that okay, this is what I can provide you, right? This is what with all whatever optimization I could only bring it to 6 seconds or 5 seconds. But in that case, how do you come up with the numbers, which is the right?
Okay. So when it comes to AI, right, I mentioned it is not a deterministic answer that we are looking at, right? We are looking at a probabilistic answer for the questions that is being asked. Now, as a best practice, what can be done is for the same set of for the same type of queries that I'm asking, right? I'll have to make sure I'm utilizing my caching better. That way, the performance of those questions can be faster. For example, let's say how much does my car cost, as well as my price of the car, still the same. The context is still the same, right? Now, if we are not using caching properly, then we are invoking the LLM or AI agents again and again for no reason, right? Now, if we are intelligent enough, or if we build intelligent enough agents to kind of understand the meaning of the context or the context itself, and then make sure we are utilizing the cache that is already built up as part of the answer, that way the response times can be faster. Now, depending upon the type of questions, things can change. Now, as mentioned, it can be 6 seconds, 10 seconds, 15 seconds, so on and so forth. So we'll have to ensure we are testing for the worst case and then try to have some timeout set. And there is no one answer for a question. That is the reason why we always have this change of, in terms of AI measurements, it is always a range that we talk about. We never go with, say, okay, this is my SLA, we stick to it and all that, right? Whereas when you check your time to first token or your inter-token latency, there you can have some definitions, right? If your time to first token is less than 500 milliseconds, let's say, it's actually good enough, right? It means that you are actually engaging the customer quicker, right? If your first token is landing quickly. Now, also when you talk about your inter-token latency, meaning like how quickly is my answers coming into the screen for the customers? If you keep it at less than, let's say, 200 milliseconds, it is faster. For the whole answer, probably we cannot have an SLA at this point, right? If we have to define, we have to make sure we have the right tools and we use our caching better and ensure we are giving the answers within the defined time. Pretty much that's what I believe. Any other questions?
Yeah. I have a question. So, like, what is the like best practice? Like, what is the protocol that we can follow? Like, what is the latest trends in WebSocket or something that we have, which can have it go on back end, front end side to have a what is it, basic latency and all those things, right, for AI application.
Sorry, can you come?
Like any sort of like best protocols or like latest trends that we can have both in the back end and front end.
Maybe I'll have to get back. I don't have that right away, but I'll have to get back on that.
Like, yeah, for streaming and all those things to keep the connection live and all those things. Just wanted to. Okay. Fine. Okay.
The discussion is about this cache management and how you measure the cache performance based on application. I have two questions. One is like LLMs can, when the context is it auto contact itself and then it will build the performance. So how do you take care of landing performance when you're measuring the performance of the AI? And the second is the overall, when you're measuring the performance of the AI will have its own cache management, and it will affect the overall performance as well. So how do you handle that?
Okay. So again, right, this depends on the kind of traffic you are expecting day to day, right? From the customer perspective, like we have some real examples of what are the queries that we can expect as an organization, right? In terms of vehicles, so we Ford as a vehicle manufacturing company, we know like what kind of questions we can expect. So earlier we used to do via search bar. Now we are using AI. Pretty much that's the only difference I see, right? But the underlying documents that you pull up, earlier you were giving it as a link, now you are giving it as a whole response, pretty much based on my question and the context, right? Now, from a caching perspective, we'll try to ensure we kind of hit unique questions in terms of when we do a load test to start with, right? In terms of understanding if the call always goes to LLM, like how long does it take, right, for the response to come back? That is the measurement that we usually do. Now, once you enable caching, so once without cache, try to understand how your real model is with the workload that you are expecting. That will give you a benchmark of what sort of performance that you can expect when such questions come in. Now, when you enable cache, what happens then? How is your system responding? Now, again, when you enable cache, it can be probably a Redis cache or it can be a semantic cache that is already available. Now, how is your cache performing there? Now, whatever was 15 seconds, coming to 6 seconds with a cache may not make much sense. It should be even faster. So that is the evaluation that we will be generally doing. So without cache, what is the response? With cache, what is the response? We'll do a comparison and see if we have to tweak something or introduce some other layers in between. It is always experimental basis, yes. And with performance, there is no, it's like how people told, right? Like not one shirt fits all. Same thing holds good here as well. Not one solution fits anything in performance.
Thank you.
Thanks.
So, again, just invite here to present.
Just basically.
Just
Thank you.
thank you. Yeah. We'll start with the session 3. So, okay, yeah, for the session 3, we do have loop engineering, and yeah, I welcome Parani Rajan here. Yeah, thanks.
Hello everyone. Okay. So the loop engineering, I started this kind of fascinated about loop engineering. But in the earlier 2 sessions, also people mentioned about loop. Like Deepak also mentioned about loop, and Praveen's session, the first slide starts with loop. So it's not going to be a new, a different context. Okay, your agents does not need a better prompt, but then it needs a better infrastructure. I'll explain about how things are happening in the world of AI. And a little bit about me. My name is Parani. Currently co-founder of N with AI. So the company which we started 7 months back, it's engineering with AI. That's what we show. Acronym was N with AI. Prior to that one, I worked in M2P FinTech, handling the head of platform engineering. And in the last 22 years, started with the Linux administrator, then turned to a proper product developer and handle a platform. Now started our own journey with AI. Some of them are the today's talk covers about the experience or the field which we faced in the last 7 months. Okay, so all this loop engineering started with the Boris Cherney, the creator of Cloud Code, is that I don't prompt Claude anymore. There are loops running, and it is the loops that prompts Claude and decide what to do. Job is to write loops. That's how he started it, and people and he given some kind of a way to measure it. Okay, we can say this is a kind of a marketing gimmick also. Like it's all today's marketing. That's behind the scenes one. Okay, he defined some kind of 5 stages. It's just to measure how organizations are at the moment and how they can move. The first stage or first step is kind of a gated. It's like people wants to do or people are currently doing traditional way of coding, or they want to move to the AI based. So that's the first step. And second step is an assistant, like a kind of a paralleling. Today, I kind of work with agents and it writes code for me. And next stage is parallel one. I am as an individual engineer, I have 10 different agents. Now I kind of orchestrate these different agents to get my job done. And the next stage is supervisor economy. Like I have 100 agents within my ecosystem, and I like managed multiple tasks with these agents. And the last one is a kind of purely AI native. All my entire organization tasks are done by agents. Today, most of the organizations are in step one. Okay, so it's because we have a Claude code, a personal level. It's a kind of a personal assistance. We are asking agents to write the code. Okay, and so there are he has given some kind of ways to measure it, how we can go from stage 1 to or step 1 step 2, and he himself says that he's at step 4, but Anthropic is at step 3. So it's like kind of the maturity of the organization. So if you today look at the Claude, how they ship the code, every day there is some kind of new enhancement is happening. How it is happening is right now they have so much of agents available, they are burning so much of tokens, but the way they ship code is kind of faster in a validated way. So that's what we are going to talk. I mean, we'll learn more about it. A little bit of kind of a context setting. So all these things happened last 18 months. So we are talking about prompt engineering. It's like you give a sentence, it will send you back as an output. That's a prompt one. And next, Andre like context engineering. It's like you give context to your agent, define some kind of an instruction. This is how you have to define. This is how I'm expecting an output. Okay, that's becoming a context. Each step is relevant. It is not an independent structure, but rather I'll say it's a ladder growing together. So we started with the prompt. Next is a context, and next is harness. Harness talks about I have an agent. How I can give or I can take power of the agents. It's saying that I will give the hands and then ask the agent to do the work. And same way in a controlled way. Let's say it's going to run in a sandbox environment. It will have some kind of a defined permission what it can do. That's become harness. And last one is recently happening is a loop. Okay, I want to be done. Different paths it has to be done. So you decide what to be done. That's becoming loop. Okay, so each stages goes from it's a learning. When we want to implement an agent, we cover all these 4 phases. It's not straightforward. I cannot go to the loop in first instance. So we need to have a proper context available. So the context is like kind of an agent will have a 1 million token. It can run within its single request. That's a context. How I optimize the context. So that's part of the context in there. And in case of harness, when there is some decisions to be taken, do I have the right set of tools and right set of permissions available so that agent can work on it? Okay. And to orchestrate all these things, the loop is going to do the work. Okay. So that's how the context has been set. And just to a little bit more about context one. So when we write instructions, we used to write things in the Claude.mv or agents.mv, right? If I take a repo, we'll say that do not delete any test. Okay, so that's been an instruction given to the agent. Agent might adhere to that one. So we are expecting agent will say that one, I'll give an example. Let's say I'm writing a new feature. Okay, in my instructions, I have a mention about do not delete test. So I wrote the feature and I push the commit to the Git, or I understand the agent has pushed the commit to the Git, and CA started running the test. And it identified it has broken up one more test case which is already running. Okay, so CA build is red now. And then this agent, how it will do is, okay, now the build is failing. I need to make the build pass so that I can create a proper VM. So it takes that one and it can make the change stating that, okay, this is not relevant to mine, I can skip it. It will try to fix it, otherwise it will skip it. Okay. Still, my instruction says do not delete it. There is no guarantee agents will adhere to that instruction because instructions are definitions available. It's a non-deterministic one, right? So it can skip and say it will skip the test and then commit it and make the build. Okay, so that's how the context one. The harness comes into place, even though there is agent has done the run. We need to have a deterministic way stating that if I have a pipe or a step in the CI, if there is a test skip is there, I should break the build. Harnesses. So you're able to relate what is the context and what is the harness. Context, why this context is failing is because there's a limit on the model can handle. Okay, and if I load 1 million context, definitely it's going to hallucinate because it's the order in which it's going to be looking at the instructions. It might skip the instructions which are the earlier set, and then it will give preference to the newly added. So that's where the context fails. When we have the harness in picture, we are making sure that it is not failing our gate. So that's it. And next is going back to our flow. Today, how we are doing things is you give a prompt, it responds, you reads it, and you decide what to do. So this is a kind of a loop. It is continuously open. In this case, you are behaving like a verifying agent or a kind of a feedback. So the bottleneck over here is, as a new individually, how things are happening. If I am going out for a lunch, yes, the loop is stopped. Okay. So rather, how we can move towards is a kind of an action, execute, verify, feedback. In this case, action, feedback, verify are going to be a machine dependable work. And execute is going to be only one model activity. And all these 4 steps together work in a loop to achieve a goal. Okay, action is the one I want to do this thing. And execute will say, I have modified this lines of code and other stuff. And verify will run the test. And if there is any failure available, it will go back to the feedback, understand the failure, and again go back to that action. So that happens in a loop without the human in the picture. Okay, so now all set, fine, everything's good. So let's implement the same philosophy in our coding. So what will happen is, so I want to develop a new feature. I gave a prompt. Okay, so the prompt is fed into the agent. Agent reads that and start executing the code, and it does the entire functionality, and it has created a 40 lines of pull request. Okay, so this is a famous loop called the Raj loop. People were using it to create tons of code because once AI is becoming a norm and the code becomes so cheap, right? Like there's a statistics in the GitHub. There is a 24% increase in the pull request compared to last year and this year because people are writing too much of code, right? So that's how Ralph loop is a one such example. I can build an application overnight. Same way, I can build a feature and then create a 40 lines of code, 40K lines of code. In that case, no one is going to read the code. And it merges with the face. And we are going to pay twice the cost just to write the 40K lines. Definitely 40K lines of code we cannot guarantee there won't be any bugs, right? We are going to rewrite it again. And it can work in a solo group. And if assume that one organization does not have proper governed process people have seen, or let's say CXOs are given a highlight, A can give a 10x productivity. A is writing so much nice code. Okay, not be written by a human also. So that's becoming a statement, right? Code got cheap, stop writing it by hand and stop reading also. So you don't need to read a code. Then what happens? You will be getting a kind of there's an increase in incidents per PR. Whenever there's a PR is greater than PR. And PR review times is 5x increase. It's like people are now adding comment, look good to me, LGTM. So and then say it's fine. We will see what happens next. Right. And then 10x is code churn. It's not new feature added, it is redeveloped again. That's a 10x increase one. And a 51% increase in PR. Okay. So that's how then if we don't adopt an AI in a proper way, we'll be getting up into this. Okay. So how we can do that? What is missing in this entire process is a verification. It's a software industry is highly deterministic, highly testable. We have built the software for 20 or 30 years one, making sure that whatever we write an input, given this input, this is my expected output. That's how we return the software, right? So, but we, in the case of AI, we missed the step like kind of verify. Okay, so without that, I give an act, I give an instruction, act on it, and ship it. But with verify as a gate, I give an act, and then the gate verifies in a way deterministically, and it can confidently ship it. That's the difference between again how we can ship lines of PR, or rather I can ship. Okay, there are a couple of determined old CI process because we want to create a deterministic software, right? We don't want to create something works. So deterministic way, we need to have proper CI in place. CI has to have a proper testing, linting, and EDE test should be there. Okay? And we can have one more non-deterministic one. So this, in the sense, it's a we can take the power of AI. So I have a story. Layer. It's a that is in our another stating called a verifying agent. It's going to be a one more agent which reads the Jira ticket or any ticket. That's an intent going into that agent, and it compares the PR. That way, it's a one more non-deterministic layer which we can as part of CI. Make sure that the output gates. That's part we define that element when I unable to decide this is the correct. Okay, when I have to stop doing it. So without this, then we'll be ending up spending so much of token cost. Okay. So now I have a proper verification in place. Next step is going into the specification one, right? Specification, typically when we do a traditional development, we understand the requirement, do the design, and so the design, everything lies on the human head. So we know what is the request must ask, and we design based on that, we will do it. But give that to the agents. Agent has to have the clear definition. So that's how we define the specification clearly. Whenever there is a single line of requirement given, okay, so you can create a proper specification on top of an existing context. Okay, the context can be your existing code base. From the code base, we can create a technical specification and create a acceptance criteria to validate the requirement. Acceptance criteria have to be rock solid. Whenever I write a new feature, is there any proper failure conditions? There is a security check, there is an error handling process is in place, are being captured. And then there is a way to properly check the validation and emit it, then we can ship the code. So that is a kind of it's a standard spec-driven development. People started adapting it very easily one. So I mean, all these things, whenever I have verification available, then I can move to this spec-driven development process. So how we can think about loop engineering in the case of an SDLC case? And let's look at one example, which means we want to move to one continuously autonomous software development process. Let's say there is a production incident happened in a night, a ticket has been created, okay, and that ticket is being triaged by an agent. So it gathers the information, it tries to pull the logs, traces, matrices from the existing system, and locate the code base, and it will not just, it will actually use the living wiki document. So wiki is a way we create an understanding about your code base. So it's a kind of an MD file about a particular repository or code base. So it will look into that knowledge, and it will reproduce the same behavior either in enterprise organization, no one will have 100% test cases. Probably it might be a 30% or 40%, 50%. So we can deploy agents to make that test cases to 100%. That's one use. And the difference in security, that's a very validated one. Now we have a proper tools available to verify the security is fixed or not, and we can upgrade it confidently if we have a loop available. And then the docs and wiki freshness, that's a critical part of it. Okay, so when we have agents available, we are creating instructions. Okay, when we expose an API, we might have started with an open API spec, which means this is how my REST APIs are inputs and payloads are. For a period of time, we missed to update. That data will go as a context when agent is writing the code. It is the hallucinations, these are all the different places hallucinations will happen. So if I have a kind of a loop available, whenever there's a new code has been written, it will go and update my state document or a wiki. That is a way to, it will reduce the hallucination in different agents. Okay. That's a different, these are different use cases. And so where you can get started. As a platform engineer, because I believe that one platform engineering role is responsible for creating a blueprint how a repo to be started, right? So we can start, there are 4 grades, L0, no verify commands. And if you have a static only, let's say lint and build process, can I have a make file in a single command? Can I create a lint or a verify that will do a lint, integration test on you or you test, and then proper fail gate, and then E2E environment. So these are the different 4 phases you can implement it, and you can do a kind of an score your repository against these metrics, verifiability, which means I have a proper build. It will actually build the artifact correctly. Proper linting available. So nowadays people started taking the lint from TypeScript and others, right? Can the agents, let's say if the agents start writing the code, is our build fail if there is a discrepancy in the architecture? Okay, that's a scale which we want to do. We don't want to say that one, just yes, I have added a lint in my CI, it will definitely will fail. It is not that one. As a senior engineer or an architect, do I have added proper rules stating that one, if I'm going to call a database query from the controller, the test has to fail. So these are the different architecture styles. The lint will be able to capture it and get things done. So that's a one layer. And do I have a cold setup? Cold setup is in a single able to running my application. Okay, so how your readme file, how good is your instruct or the make file? So that's a cold setup one. And the agent context. Agent context is a key one. Let's say I have learned how many. When we started development, we were given some kind of instruction file. A month on month, we never will go back and read the instruction file. It might be stale. So how frequently we have to update the instruction file? That's a one more check we need to do. And the guardrail. Guardrails are for scan, test, and code also. So this will help you to grade your repository. And so you can do an audit. Again, it's the same one. Like, do your agents have an instruction file, and the instruction captures the conventions, what kind of an architecture. The instruction does not say that one so things loosely. If let's say I have a product and which has which is connecting to multiple microservices, can I have an instruction file which will talk about how different microservices are connected, which API connects it? Those are all kind of conventions can go into the context. And yeah, I talked about the linters. So linters should be act as a kind of an architecture or an architect. Okay, and CI one. So before I merge the chain, the CI has to be completely green. Okay, whether the same instructions I do it locally or in the CI, it has to behave same way. And last one is a critical one, like what are the failures which we have learned? Are we updating our baseline? Today we might have a 30% as a baseline on the code quality might kind of secrets in a previous one. So we should not become standard, and after that agents to write code. So this will help you to judge your repositories, or is that ready for a coding agent? So one process is like so we have a different instructions. So it's all the ADRs are linting, everything's an instruction file, right? So we can consolidate all these instruction files as in a centralized repository, just named as an engineering standards. Okay. That will be used by agents, and the same way it has to be available to the runners also. Runners cannot use a different instruction file. So both the instructions has to be the same. And the services also, the individual microservices or those repos also should refer to the org-wide or project-wide standards. Okay. How we can expose this? We can now kind of a generic config server, which is common for the CI and dev laptop. It reads the instructions from a common repository, and whether it's agent running in my local or running in the CI will behave the same way. It's a kind of a one pattern which you can try it out. Yeah. So those are kind of concepts which I want to share. And we, as an organization, also we started this principle like trustworthy, repeatable, agentic, collaborative engineering before we start developing our product. And we kind of debated for a week and say how the coding or the AI will help in programming. That's how we have identified this one. And specifically kind of a trace, task, define, act, check, and emit. It's a kind of a loop one. So if I want, and it's actually going back to the specification one. So I have a proper specification available. I have a proper specification available. I have a proper way to create a validation environment and execute. Okay. So that's how we build a product called grouping. It's group for product. So how we want to how we can take SDLC in autonomous way, autonomous coding. A wiki will be created. How we can take SDLC in autonomous way, autonomous coding. Let's say that the wiki will be used to, will be fed as a context to the agent, and we can create a specification. We'll have the specification will have acceptance criteria. We also have a coding agent run on the server side, giving this context and taking this clear definition as a specification and execute the codes and check it into the Git. Okay. So that's how, so the key takeaways are how we can use AI to clear the tech debts. So what are the validation I talked about? It is just about we were using it for, or we were having this backup for so many years. Given as a human is writing a code, we are confident that whatever the code is written is working fine. When we shift back to agents, we need to have a deterministic test the code. These are all the, we use AI to amplify those backlogs. We can do faster. And I've also mentioned about how we can start our grading your repository. Yeah, that's it.
So two questions I have. I'll go with the first one. So you mentioned that you will be putting all the MD5 rule of instructions what the agent should follow in a centralized record, right? So as a developer, let's say while giving the prompt, I give 10 lines of my own local guidelines, and I'm telling it strictly follow these. And what if these guidelines doesn't obey or matches with the one which is there in the central record? Then the agent will follow which one? My local guidelines or the one which is there in the record?
So it's again a non-deterministic answer only. And more, most of the times it will take your local because that the precedence comes one. When agents look into the context one we talked about earlier, and whatever you are overriding, it's becoming most likely it will take your one. If there is any contradictory, nowadays the agents are becoming much more intelligent. It will say, you talked about here, this is a strict rule or a Bible, and you are contradicting over here. Do you want me to override? It will ask as a human layer to override. In this, you are acting as everything is runs on your own laptop. Making sure that things are being
have a uniform way of coding, right? Because all the developers can manage their own.
Correct. Yes, that's the intention why we want to move to the specification driven development is you cannot, we have seen when we are interacting with our customers or the teams one, let's say there is a small, don't go for 1,000, that's a huge group, right? Let's take the case of a 10-member team. There are two Star Wars, two guys are really good, they can start writing or they are using specification driven development to develop the feature. The rest of the eight guys, okay, there's a story given to me, I start doing it, I kind of keep on prompting, I'm not doing it. So the productivity is, they are unable to implement the process within this 10 members also. Okay, so that's how this, the framework called BMAD or a spec driven or open spec achieve it. And within our platform, what is like, let's take away way to give that to the engineers. They are sloppy, they are not ready to do that one. Rather, we create a specification as an agent side, give that context back to the engineer. Okay, you review it and then say, start coding it. So that's a practice which we are trying to solve.
Okay, yeah. So the last question is like, you mentioned that loop diagram, right? That first approach you told is the one which we send the prompt, then it processes it, then it comes to us, we read it and then respond. So this is the one which classical I think I'm following or the others are following. And the second one you told the we need to do action, evaluate or execute something like that. So my question is, in the, let's say I'm a front-end developer, so I'm using that Codex one the ChatGPT is having. So currently, I'm following the traditional like I read the prompt in agentic mode. Whatever changes it is doing, I'm just checking them, then accepting them, and then letting it in the code. So the loop concept which you were mentioning, so is it already there, or someone has to build it, or it is in the process of building, or how it is?
Okay, so Claude and Codex, I know they have a concept called the loop. So you can define a goal. It actually creates multiple sub-agents, and to achieve the goal, it will start creating the, I'll say it will make changes and grade it, it will do a score. Okay. There is a one agent writing a code, another agent will do the score and say the score is matching more than 80% and it will shift the code. That's a one loop. This concept is available in the Cloud Code and Codex. Okay. Again, it's still one line statement converting into a code. But if you want to get the full power of AI, you need to go for specification. You need to write a proper specification, read the specification and approve it, and ask agents to write the code. Without that, again, you will be sitting and doing the prompting. Okay. Before, let's say you got a ticket, you ask agents to create a full specification, full acceptance criteria. You review it and say, give that specification to the agent. Agent will do the job perfectly.
But still in the loop approach also, like the developer has to verify it, right? So again, it has to wait only now.
Yes.
It won't automate everything, no?
Yes, that's what we are going to. The verification is going to be a key part. Let's say when I write a new feature, we need to have a proper testing. That's what when we review the validation or acceptance criteria, do I have enough test coverage has been created for that or not? That's the engineer's job. So engineer's job is, if I'm not writing the code, then what's the problem of having an engineer, right? So role is slightly shifting. We are trying to be a human intelligence as the topmost one, right? We are saying that instead of you don't write the code, rather you curate the agents. You just review the specification. This is what an agent has to do.
How to know which model is following this loop-based approach?
Sorry? Yeah, model does not follow. Model is just a dump. You give an input, it is.
The agent, like, let's say you don't only cloud is following this or ChatGPT also. Loop-based approach.
Okay, I've seen about Claude and Codex. Maybe Grok also will do that one. I think they have a Grok builder.
If you ask
These are all coding
AI,
agents.
it will say, right?
I'm sorry?
I'll ask the AI only, are you following traditional or the loop-based approach?
No, it will not spawn unless you create multiple agents. That's how there's a skill within the Claude, let's say /loop or give a goal, it will create multiple agents and do the loop.
Thanks, Amit.
So how does this system regarding the token, does it manage tokens, the number of tokens it is being used? How does it manage the tokens?
Okay, so the Claude code when you create multiple sub-agents, it's going to obviously create multiple tokens. Definitely token usage is going to be higher. That's where the context engineering comes into the picture, right? When you, as a developer, there are two ways to answer it. How we are solving, I will answer it we are trying to create a central knowledge. You have hundreds of repositories available. We create a central knowledge, doing a proper ingestion, and other stuff, creating a proper wiki which agents can understand. That data is going as a back to the developer laptop via MCP. So when agents work on it, it can connect to a central knowledge and get relevant context. The context will say, if I'm going to access an API, it will give a complete call trace. It will give a complete radius analysis before I make the changes. That way, we can optimize the token usage. That's one approach. Okay, and we have measured that also. Otherwise, if you give a code, or I have 10 repositories available, and ask agents to create one feature which touches 3 different repositories, within you will be bloating your context and wasting the tokens. We have seen it.
Can we set a context window? You can control the context window of the agents.
I'm sorry.
Context window that we can also manage.
We will not be able to manage the context window. See, when you do the compaction, it will lose some of its understood content, right? So that's why instead of giving an entire, let's say, that's why we need to have multiple agents. Within that agent, we just give only the relevant data. We don't need to pass the entire context into them. For example, there's a coding review engine. I have a wiki available, and it will have an architecture pattern already defined. Take that pattern and use it. That becomes a little bit of context, right? Otherwise, it will start understanding the entire code base, and it will create what is an already existing architecture pattern. Then it will start doing the reviewing the code. So it's again, it's a multiple gates, multiple stages. Then only we can achieve the content, get the power of context.
You want to say if you give its own knowledge base, then I think will give the optimized.
Correct.
Instead of going to a centralized report, we can create our own agents potentially and specific agent amplifier. So that is more cost effective.
No, let's say I have 10 different engineers. I'll be doing the same job 10 different times. Today, we are using a per seat license from a Cloud Code or only Cloud Code is giving a per seat license. Within your token limit, you you are burning certain number of tokens. The developer B also burning same tokens. Rather than if there is a central knowledge available, they are just going to refer the already indexed data.
And maybe it doesn't cost analysis, how much this would save rather than human and
On the context basis.
common is costly.
No.
Because you're paying both, you're paying the cloud, you're paying the engineer.
So that's a qualitative way, not quantitative. It's a
Yeah.
qualitative.
Yes.
The first question was on, you talked about the engineering side. So when we want to do the engineering part of this, right? So how we need to take care of all the system design aspects before it's then generating the code.
Okay, so you are starting a new project or there is already a new project. Okay. New project depends upon the scale. Nowadays, people started creating small applications. SaaS is becoming dead. Okay, I'll give an example. I was talking to one 80-year-old gentleman, visionary. He gave an example about how people are building houses. Okay, as an individual, I can build a house. If I want to build an enterprise, I will go for a high rise. So if I'm able to build an application for myself, similar to how I build my houses, that's a trend we are moving towards. I don't build a high rise where I need to have so much of constraints, enterprise guardrails, thinking about it is going to scale like a UPI based volume, or it is going to be a kind of a personal finance. I'm going to give it for about hundreds of subscribers, and then it depends upon what kind of an application we are going to build.
Second one, you talked about architectural linking tools.
Yeah.
Can you give me some specific examples?
Okay, so when we talk about lint will, by let's say TypeScript one, TypeScript lint will have a certain kind of a style. Okay, it should not have, the parameters has to be in this fashion, and I should not. The test has to pass another step one. So, but the good lint will be as an architect. For example, when I'm going to pass or a controller, the controller should not directly call my repository. That's a one rule has to be. So,
For architectural, I'll be looking at the spec engine other than.
correct. So that. I'm sorry.
Any linking tool available which can do that.
See, ES does most of the things, but the kind of a rule what we want to write it. We can ask agents also to understand our repo and create one rule repository. It will, based on my current code base, these are the patterns available. I should not introduce a new pattern. When an agent's writing the code, it should not introduce a new pattern. So it has to follow the existing pattern and start writing the code. That's one way of doing it. Another one is someone has to literally review all the rules and stating that one as a senior engineer or senior architect. When I write the code, I will be expecting these rules to be there. Then that's what I'm expecting from the agents also. So instead of
I'll go back to your diagram. There are agents and there are a pipeline which can resolve all the AC or spec or RFC and then agents and then linking tools. And then that is going to the CRM and then it's producing spec agents, different agents generation.
Correct.
This is all generation pipeline which automatically happens, if I understand correctly. So the agents could be changing. The agents could be adding one more agent to that entire pipeline based on this way.
No, little bit correction. So if I mean the thing is about the agent's instruction file. It is agent can provide, create. Human has to review. That's the objective. Okay. To review the instructions. If I'm not reviewing the instruction, we will not guarantee the deterministic output.
One last question. So, is the loop engineering in the system problem, or is it like we need to take care of the
In the loop engineering system prompt?
Is it a system problem, or is it like we need to prompt it
Prompt, I won't say prompt will be a problem. Prompt will be a problem if you are going to use different models. For example, if I take a prompt which is written for Cloud Code or a Opus, I cannot use it for a Gwen 2.5 model. That's a very small model. That can, okay, I will give a small example. Let's say I want to fix a small bug fix. Via my loop engineering, I have a coding agent available as part of my pipeline, or I have an automation available. That small bug can be fixed by a small agent. We don't need to burn the Opus cost. Okay, but the prompt will differ. But it is more of a context. So context, how we are going to manage the context. Am I going to load all the instructions at one shot every time? Or only the relevant instruction is going to be read by the model. That's the context. So the system prompt will differ between agents, and we need to curate it in such a way it sees only the relevant context.
Have you guys used that headroom? There is one.
That's just again a cost effective. It is one more way of compaction.
But they claim that 6,000 tokens versus 60,000.
Yeah.
90%.
It might lose your context in some other way. You have given one liner. See, we have observed a pattern when you define not condition, you should not do all these things. And the initial one, and when the context goes up, it actually forgets a negation.
So with loop engineering, right? So obviously it runs multiple loops to get the right items output. But if there's any issue, since it's executing by autonomous delegations, and if there's any issue, I feel like it becomes very difficult for debugging or auditing purposes. So how exactly you have incorporated those tools?
So the exit condition you're talking about, when there is a loop is running, there has to be an exit condition. As part of our framework, we have defined some kind of first loop success rate. How many times a loop can write? What is the break point you need to stop? So again, three things. One is the first loop, the iterations. How many times when a loop has to be the defined number we can define. And then the next one is kind of the stop gate. It's going to be a determinant when I'm trying to solve an issue. If it is failing more than 2 times, stop it. That's how we have to escalate it. If you don't have a stop conditions, yes, it is going to loop continuously.
Even after running everything, right? So we did run and get a generous output, but sometimes it's not giving us the right output or some issues, right? In that case, how do you debug it with this loop engineering also?
It is again a subjective one.
Okay. And okay, then like with loop engineering, right? Obviously, the tokens we are going to number of tokens is really high, and we have to have a way of context engineering, fabric engineering, just to make sure that we don't consume the tokens as much. But how do you make sure that the latency is handled? I know this is like when it comes to multiple loops, your latency gets impacted. But how are you handling that latency button?
Latency from the LLM side of it, or it's
and that's loop engineering perspective.
Okay.
If I run it in single loop, I know, but based on it, to get the determinants output, it will definitely run multiple loops, right? Just to make it, as you called it, we are not going to prompt it. It will only keep changing the prompt so that it gets the right output, right? In that case,
so what we have seen is in a scenario where we consider as items. The first to achieve the goal, the first iteration is going to be somewhere around 75, and then on the second iteration it will be somewhere around 80, but we are expecting goal, right? So on the third iteration, what happens is that 80 will go down to 75, and 4 will go to 70. So we are seeing those things along a proper context and those things maximum. So and then based on the maximum and based on the time, so that choose as we go. And
everybody backend application, and that was a major use case.
Yeah.
Otherwise, it cannot be, this cannot, like, if there's a latency of like 10 seconds, 15 seconds, then you cannot have Google generating where it will get you deterministic output.
See, I mean, if you look at these trends, probably down the line in 5 years, we will absolutely will not write any development, right? So it's moving towards how we want to define an intent. These are all building blocks. I feel these are building blocks will achieve it. If I need to have proper validation. It's not saying that one we don't need to write the code at all. Yes, those things will be there. Rather, we write the code, we are going to define some kind of proper constraints. That's all.
And obviously, so it's the question, right? Since I'm not writing anything, and obviously, like, I don't know what the role of engineer, but when you ask, like, you have to tell the code, if you ask, you need to review, I only review at high level. I would like, the code which I have done by hand, I know depth and everything of that. I know what impacts. But when I'm not writing code by hand, right, it's only high level review what we can do it. There could be still some of the steps which we would have missed out by writing a hand, code in hand, we would have definitely caught it. But that's there, but
That's the validation part. Let's say, see, definitely A is going to give you 100, some of the validation which you have not thought about also. It's our responsibility to go through it and give proper inputs again back as a feedback and make sure that the validation is correct. Yeah, human in the loop, just to make sure the specification, whatever the spec we are writing is clear.
And also automatically you put a testing agent and then do that.
Correct. See, it's an iterative process. Let's say I write it, and then when we have a proper guardrail, the linting and other stuff available with as an architect kind of stuff, again, we are going to ask the cloud to behave like a senior architect and start giving this one. These are all kind of an instant, we are prompting it to get the data, right? And putting it back to the guardrail. So that the deterministic ways is still safe there. And when we say, when we have a step in the pipeline, there should not be any test skip in the code base. Obviously, it will make sure that all the tests are
What happens if the token cost increases?
Yeah, there are multiple, I mean, within $20 1 month, they changed from giving competition to the frontier one. I don't see it's going to increase drastically. It's going to be a mixture of open source and then the proprietary will be there in the future.
Thank you. Yeah, thank you. Yeah, I was trying to present a token. Mine.
So I request Bala to.
I'll not take much time. We are standing for the lunch. I have two things to say. One is a big shout out thanks for all the teams from Bangalore, the people who are coming here. Around 11 people have come from the professional background and excellent questions. I couldn't believe how you guys really articulate this and ingest and then ask a very sensitive, super insightful questions. So thanks a lot for coming here and then asking those questions. Though the number is less, but you guys actually fulfilled and surpassed the expectations. So thanks a lot. And I have around 15 of my 4 friends also. Thanks a lot, team, for showing up. I also thank the Foodland team, HR team, Govinda, as well as Praveen, and everyone from my organizing team, starting from Anbu, Oscar, Kamali, Raghav, and then the speakers. So Parni, thanks a lot, Parni. We are coming a long way, going with our meetups in M2P and then till now. So thanks a lot finding your way here and then supporting us. And we will have more interactions in the days to come. And Deepak, excellent session. Praveen, in spite of your illness, so you find your way here. Really grateful to you. So thanks a lot, and nice to meet some nice friends. So Bharat, Santosh, and many of you. So thanks a lot for showing up. We have plenty of food available. If you want more packets, please feel free to take it. We have ordered for almost close to 50 plus, so we are hardly 25. So feel free to take more for your home and for your evening as well. So with that, we will just go out and then take a picture. By then here there will be tables so that we can eat as well. Otherwise, if you want to take, then take it in the home also, that's fine. Thanks a lot, team.
Video is there.